Hi students, I hope everyone doing well. Today we are back with a new theorem which is converse of Pythagoras theorem. In the last class, in the last video, we discussed what is Pythagoras theorem and we proved it, correct? We done the proof also. So what is this converse? While we were discussing converse of basic proportionality theorem also we discussed, what do you mean by converse? So similarly here, converse in the sense we are like, for example, let me explain what is the statement. Just let me recap the statement of Pythagoras theorem. In a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. That is the statement of Pythagoras theorem, correct? So what do you mean by converse? It means here just we are doing the other way around. It means, as I said that, okay, anyway, I am giving the example once again. Like, just like we are saying the statement in the other way. For example, Rama killed Ravana. Ravana was killed by Rama. See the difference between these two statements. Rama killed Ravana is an active verb. Maybe it is related to English, but I am just explaining the meaning of converse in this way. Rama killed Ravana is also a correct statement, and Ravana was killed by Rama is also a statement. So both are correct. Maybe first one which I discussed is a statement related to active voice, and the other one is passive voice. Similarly, both the statements are correct. In both the statements there is no change in the meaning. Meaning remains same. At last, what I need to say you that I said. Usually what is the meaning of the sentence? Rama killed Ravana. Maybe Ravana got killed by Rama, both are same. So here also, what we are doing here, the same statement only. Means, here, let me explain this. In a triangle, the square of one side is equal to the sum of the squares of other two sides. Then the angle opposite to the first side is right angle. Exactly, you remember the Pythagoras theorem statement. It means in a right angle, this is there first. Correct? This statement, what we written at the last is first. In a right angle means, in a right angle, if the square of hypotenuse, okay, the square of hypotenuse is equal to the sum of the squares of other two sides. Okay? It means what we proved. Okay, in a right angle triangle, we proved that the hypotenuse square, it means AC is, as I said you, longest side is hypotenuse. So, in a right angle, AC square is equal to sum of AB square and BC square. Correct? It means AC square is equal to AB square plus BC square we proved. Okay? And there it is already given, it is in a right angle. They only given it is a right angle. Here, just opposite to that. It means they are giving that AC square is equal to AB square plus BC square. They have only given that. In a triangle ABC, AC square is equal to AB square plus BC square. If this condition satisfies, the triangle what you have chosen is a right angle. Sorry, is a right angle triangle. Right triangle. It means in the before case, in a triangle, in a right triangle, we proved that hypotenuse square is equal to the sum of the squares of other two sides. But now they are giving that hypotenuse square is equal to sum of the other two sides. Then what we have to prove? If this condition satisfies, then we have to prove that the given triangle is a right angle triangle. I hope you understood this. Okay? So let me explain once again. In this case, what they are giving, they are only giving that AC square. They are not telling this is a right angle. They are just telling in a triangle. In some triangle, in any triangle, AC square is equal to AB square plus BC square. Means longest side square is equal to sum of the squares of other two sides. Then the triangle in which this condition satisfies, that is a right angle triangle you have to show. And also, and the opposite here. Then the angle opposite to the first side. For example, angle opposite to the first side. What is the first side? You can take this is the first side. AC. Opposite to the AC is B. In this triangle ABC, if you consider, okay, this here. Angle is equal to the sum of the squares of other two sides they are telling. That's the reason. Other two sides are what? AB and BC. Then what is the first side? AC. Remember, it means first side is this second side is this, and third side is this. It means they are telling the angle opposite to the first side. We assumed first side as AC and we assumed AB and BC are other two sides. So angle opposite to the first side is angle B. So we have to prove that angle B as a right angle. If you prove that angle B as a right angle, then definitely triangle ABC is a right triangle. It means right angle triangle. I hope you understood. Let me go with the given case. What is given? As I told, clearly given a triangle ABC in which AC square is equal to AB square plus BC square. This will take the equation 1. It means they only given in a triangle. Remember, everywhere you can observe this. In a triangle, they are not telling this is right angle triangle. They are telling this is a triangle. In a triangle ABC, AC square is equal to AB square plus BC square. That is given. What we are constructing? We are constructing a triangle C. Already what we are taking ABC here. Okay, triangle ABC. We are constructing or we are drawing one more triangle PQR. Okay, and this triangle is right angled at Q. Means we are constructing in such a way that, and we are constructing, we know this is a right angle. Okay, we are constructing in such a way that this is a PQR is a triangle and it is right angled at Q, means this is one right angle, and also we are taking the sides in such a way that PQ, if this is 2 centimeters, sorry, this is 2 centimeters, we are taking PQ as also 2 centimeters, and QR should be equal to B. If this is 2, this is 2, and this is 1.5, we are taking this as 1. With the same measurement we are constructing. How we are constructing? We are constructing a triangle PQR in such a way that AB and PQ length is same, and as well as BC and QR length is same. We can construct, correct? And also we told and we construct in such a way angle Q is a right angle. We are not telling B as a right angle. We are telling angle Q is a right angle. Okay? Again I am telling we are constructing a triangle PQR in such a way that AB length and PQ length is same, BC length QR length is same, and angle Q is a right angle. So like that we construct. See, draw a PQR right angle to Q such that PQ and AB are equal, QR and BC are equal. So once we construct this triangle PQR, proof. Now we are doing in triangle PQR. In this triangle PQR, angle Q is 90. Why? We are only construction. Correct? We constructed like that. We constructed that such that angle Q is 90 degrees. So angle Q is 90 degrees, and if angle Q is 90 degrees, we can say that triangle PQR is a right angle triangle. Correct or not? How can we say? Because if one angle is 90 degree in any triangle, that is considered as a right angle triangle. So we consider and we came to know that triangle PQR is a right angle triangle. If that is right angle triangle, you can apply Pythagoras theorem. Correct? By using Pythagoras theorem or by Pythagoras theorem, what Pythagoras theorem statement says, the square of the hypotenuse is equal to the sum of the squares of other two sides. It means PR is the hypotenuse here, PQ and QR are the other two sides, correct? So PR square should be equal to PQ square plus QR square, correct? And also in the construction you see, PQ and AB are equal because we constructed like, and QR and BC are equal. So can I substitute in the place of PQ, AB? So can I write PR square is equal to AB square, in the place of QR I can write BC. So PR square can be written as AB square plus BC square. What I am doing, instead of PQ I am substituting AB, instead of QR I am substituting BC because we constructed for the same length. Already it is there. From the construction we are substituting and we know that they are equal. And this we take as equation 2. See now from 1 and 2, from equation 1 and 2, from 1 and 2, okay, look at this, there here RHS is AB square plus BC square. In equation 1 RHS, AB square plus BC square. In both the cases, RHS are same. Right hand side of both the equations are same. So what I can do, I can equate LHS. So AC square of this and PR square is LHS here, AC square is equal to PR square. If this AC square is equal to PR square, definitely AC should be equal to PR. It means we proved that this length is equal to this length. I know, right? I don't thing, so it needs explanation. If 2 square is equal to 2 square, then obviously 2 is equal to 2, right? Correct. Squares will cancel. Definitely you will get 2. Obviously, right? If 2 square is what? 4. If 4 is equal to 4, definitely 2 should be equal to 2. This is a simple explanation. Okay? I hope you understood. Okay? That's why. In both the sides, squares are equal. Even the bases are equal. You might be knowing this exponent formula. Okay? In 7th standard or 8th standard, you might have studied. In both the sides, exponents are same. Then bases should be the same. That is the thing. Okay? Base should be the same. Here exponents are same, correct? Exponents are same, that is the reason we can write basis AC is equal to PR. So we proved that AC is equal to PR. This you take it as equation 3. Now we are considering two triangles, triangle ABC and triangle PQR, and we already proved that AC is equal to PR, and from the construction part here, from the construction we know that PQ is equal to AB, or you can write AB is equal to PQ, both are correct. AB is equal to PQ, correct, and what is that? BC is equal to QR. This is by construction. Okay, by construction we know that this three sides are corresponding sides are equal. It means AC is equal to PR. See, AC is the corresponding side. AC is equal to PR, AB is equal to PQ, and BC is equal to QR. So we proved that the corresponding sides of these two triangles are equal. If the corresponding sides of these two triangles are equal, then what we can prove by, you might have studied in 9th standard, by SSS congruency, side, side and side, correct? If all the three sides are equal, by side, side, side congruency, we can conclude that triangle ABC is congruent to triangle PQR. Okay, triangle ABC is congruent to triangle PQR. What do you mean by congruency? I'm just revising that. Congruent, if any two triangles are said to be congruent. Want to confirm that if any two triangles are said to be congruent, how can we say that they are congruent? The corresponding side should be equal, and also the corresponding angle should be equal. Not only the side, even the angles, corresponding angles of the triangle should be equal. It means if these two triangles are equal, we already proved AC corresponding sides are equal. So AC is equal to PR, AB is equal to PQ, and BC is equal to QR. Similarly, angle A should be equal to angle P, angle B should be equal to angle Q, and angle C should be equal to angle R. Then only we can say that they are congruent. Correct? We already proved they are congruent. Can't we say that angle A is also equal to angle P, angle B is also equal to angle Q, and angle C is equal to angle R. This you might be knowing by CPCT. What is this CPCT? Corresponding parts of congruent triangles. You studied in 9th standard. CPCT. By CPCT, even we can say that corresponding angles are equal. And what we need to prove that angle Q is 90 degrees, correct? So what is angle Q? See there, right angle at Q. What do you mean by that? We constructed in such a way that the triangle PQR we constructed in such a way that angle Q is 90 degrees. So already we written here, clearly specified angle Q is 90. If angle Q is 90, we know that angle Q is 90, then what is angle B here? Angle B is obviously 90 degrees, because angle B and angle Q are equal, and angle B should be equal to 90 degrees. Correct? So what is angle B? That angle B is the opposite angle to the first side of the triangle ABC. So we proved that angle B is equal to 90. That is only the opposite. Okay? So hence proved. It means what? We taken the condition that AC square is equal to AB square plus BC square, and we proved triangle ABC as a right angle triangle. In Pythagoras theorem, what you did? They only given that triangle ABC is a right angle triangle, and we proved AC square is equal to AB square plus BC square. Just you remember the statement that Rama killed Ravana. They said Rama killed Ravana. We are saying Rama, like Ravana was killed by Rama. That's all. Converse is just like that. Okay, I hope you understood. I'll explain once again. And this is also one of the important theorems according to your examination point of view. Okay, I'll just repeat this theorem proof once again. Yeah, let me explain the statement. In a triangle, see this a triangle in the sense they are not specifying triangle is a right angle. They are not specifying anything. It may be any kind of triangle. In a triangle, if the square of one side is equal to the sum of the other two sides. In a triangle, sum of the square of one side, and I'm assuming that in a triangle ABC, first side is the longest side. I'm assuming like that. AC hypotenuse, so that I'm taking the first side, second side, and third side. I'm assuming like that. So according to them, the sum of the square of the first side is equal to the sum of the square of the other two sides. If you able to, if this is happen, if this condition satisfies, then angle opposite to the first side is a right angle triangle. It means we have to prove that if this condition, for example, in a triangle ABC, we are able to prove that AC square is equal to AB square plus BC square. Then they only given that in a triangle AC square ABC, AC square is equal to AB square plus BC square. If this condition satisfies, then we can prove that angle B is a right angle. What is angle B? Angle opposite to the first side. Remember, you don't get confused. Okay, what is that angle opposite to the first side? Angle opposite to the first side is angle opposite to the longest side. Okay, so that is AC is the longest side. So for that opposite side is angle B. So that angle B only we have to prove it as 90 degree. Okay, right angle. Okay, I hope you understood what exactly we are telling. The square of the first side is equal to the sum of the squares of other two sides. It means AC square is equal to AB square plus BC square. If this condition satisfies, and they only giving clearly given that this condition is there. AC square is equal to AB square plus BC square. If this using this, or we can use this statement, and of using this statement we have to prove that angle B, which is the angle opposite to the first side of the triangle ABC, as a right angle triangle. So what we are taking, we are assuming that, or we are given that, it's not an assumption, given a triangle ABC in which we have given a triangle ABC in such a way that AC square is equal to AB square plus BC square. This you take it as equation 1. Next, construction. We are constructing one more triangle PQR. Okay, and this triangle PQR is right angle at Q. Yes? While constructing only, we know that this is a right angle. It means angle Q is the right angle, and also the same length. For example, if this is 2 centimeters, with the same 2 centimeters I constructed PQ, with 1.5 centimeters is BC, means the same 1.5 centimeters I constructed QR, and CR we don't know. Only these two are same. Remember, PQ is equal to AB and QR is equal to BC. Like that, with the same measurement, we constructed triangle PQR. Okay, we are constructing triangle PQR in such a way that AB and PQ are equal, BC and Q are equal, and angle Q is a right angle triangle. This much we did. That is the construction part. What is the proof? We are considering triangle PQR. In triangle PQR, we know angle Q is 90 degree because we only constructed like that. Correct? Angle Q is 90 degree, and clearly specified this is by construction. Okay? So, and we came to know triangle PQR is a right angle triangle because angle Q is 90. Correct? So, in a right angle triangle, we can use Pythagoras theorem for a right angle triangle. Correct? So, by Pythagoras theorem, what is Pythagoras theorem? Is the longest side square, which means hypotenuse square. PR square is equal to PQ square plus QR square. So, PR square is equal to PQ square plus QR. And we know that from construction, PQ is equal to AB. It's already in the construction, we already know that. And QR is equal to this. In the place of PQ, substitute AB. So, PR square is equal to AB square, and QR you can substitute this. PR square can be written PR square can be written PR square is equal to AB square plus BC square. Instead of PQ, QR, we have substituted AB and BC. So, this you take as equation 1 and 2. From equation 1 and 2, you observe the RHS of both the equations is same. Correct? When RHS of both the equations are same, we can easily equate the LHS. Because if RHS are same, then LHS should be equal. So, AC square is equal to PS. In this case, you see both the sides exponents are equal. As we know in the 7th or 8th standard you might have studied, if in any equation both the sides exponents are equal, then obviously we can equate the bases. So, AC should be equal to PR. So AC is equal to PR. That you take as equation 3. And in triangle ABC and PQR, we know AC is equal to PR by, we got it, we just proved that. And AB is equal to PQ and BC is equal to QR already by construction we know. So in any two triangles, okay, corresponding sides are equal by using or by SSS congruency, we can say that triangle ABC is congruent to triangle PQR. This means we can we can conclude that those two triangles are congruent to each other. In these two triangles are what? Triangle ABC is congruent to triangle PQR. This you studied in 9th standard. And also, if these two corresponding sides are equal, okay, but what about the corresponding angles? In congruent triangles, not only the corresponding sides, even corresponding angles should be equal. So, corresponding angles also be equated. So, angle A is equal to angle P, and angle B is equal to angle Q, and angle C is equal to angle R. Okay, this we can write, this is very important, you should write by CT. Okay, it means congruent parts of corresponding, okay, triangles. Okay, now you can write corresponding parts of congruent triangles. So we know that angle Q is equal to 90 degrees, because why? We already constructed like that. See, clearly in the construction we specified it is right angle at Q. It means what? Angle Q is equal to 90 degrees. If angle Q is 90 degree, angle Q is equal to angle B. Correct? If Q is 90 degree, even angle B should be 90, because angle Q is 90 means angle B is equal to angle Q. Correct? If angle Q is 90, definitely angle B should be 90, because both are equal. So we proved that angle B has 90 degrees. It means what? We proved that the angle opposite to the first side of the triangle ABC is 90 degrees. It means we proved that triangle ABC is a right angle triangle. Just it is opposite to the Pythagoras theorem. Okay, I hope you understood, and it is important for your examination point of view. And I am repeatedly saying, usually Pythagoras or converse of Pythagoras or basic proportionality theorem. Most of the times, chances are there they may ask you, they repeat it. So that's the reason we stress on this, basically on these three theorems. Okay. Thank you very much. Please like, comment, share and subscribe and support us, and inform your friends to support. Take care.